Good morning. Okay, now we're going. So we are in pre-algebra. I've already sent you to Summit Learning Functions and Volume, Day 8. And here's kind of what we're going to go through today. We're just going to go through basically all the activities on Day 8. I've got those on my screen, I think, in the correct order so that I can share them with you and we can go through them while you're looking at them on your screen. So I can see your chats. And if you ask Day 8, yes. So if you ask questions or respond to a question that I ask, then then you'll be in the right place, and I can help you out there. Okay. Um, Here we go. All right. I think there it is. Day 8, Activity 1. Which one doesn't belong? That is the warm up. And so I need to zoom in a bit there so we can see that better. Which one doesn't belong? Which graph does not belong? So if you got that going in your chat there, I can see your replies. Which one does not belong? Somebody's got to reply in order for this to work. B, okay. I'm getting lots of different answers. That's fine. So give me which one and why you say it doesn't belong. So I like that you're replying and answering. So I got several that said B and several that said D. So one of you that said B, give me a reason why B doesn't belong. One of you that says D, give me a reason why D doesn't belong. Typing time takes a minute here. Okay, so D is a dotted line, and that was the first thing that stood out to that person there. So, okay, I like it. That's a good response. I totally get that. And somebody that answered B said B doesn't belong because it doesn't pass the line test, is what they said. And that B since it doesn't pass the line test means it's not a function. The other three are functions. A, C, and D are all functions, but B is not a function. That's a good observation. So if that's your standard, if saying we're going to throw out anything that's not a function, then B doesn't belong. But D also makes sense. Anything maybe that is just a dotted line we're going to throw out. That doesn't belong. So D makes sense as well. And then somebody said A and B are both weird. A and B are different types of graphs um, than we have experience with up to this point, as far as they make curved lines and not straight lines. When we get into algebra, my algebra class, we'll be getting into doing some things that look like A here real soon in algebra class. So you'll be doing those kind of things next year in math. Okay. As always with these types of warm-ups where it asks you to choose one that doesn't belong, there's usually a way to make all of them the one that doesn't belong, right? So we could say C doesn't belong because C is the only one that involves straight lines. The others are all curved. Even D, if you connect all those dots, would be curved, right? Um, and C is the only one that would have straight lines. So I guess there's a way to make all of them the one that doesn't belong. All right. Well, that's good. It gets us kind of thinking about some math concepts and some math things as far as looking at graphs and interpreting them and thinking about them in that way. So go ahead and go back to Summit Learning. Go to the activity directly below the warm-up, which is time and temperature. By the way, guys, Miss Martin is on GoGuardian, so she's watching and seeing that you're on there, and she can send me text messages and chats and stuff, letting me know if I need to call somebody out. So please just make sure you're following along. I know this isn't the best way we could do school, but it's what we're doing. So uh, we gotta keep up. So activity directly below the warm up is time and temperature, and that's the warm up. It should look like this. Should see time and temperature, and it has a graph on it. Okay. um, okay. So Summit Learning, day 8, activity 2, time and temperature there. And okay, whoops, I need to fix that. All right. Okay. So the graph shows the temperature between noon and midnight on one day in a certain city. And then it said, was it warmer? So we're just going to answer these questions. This is about interpreting things on a graph, making sure that we know how to read graphs correctly. So question 1, was it warmer at 3 p.m. or 9 p.m.? Was it warmer at 3 p.m. or 9 p.m.? All right, thank you. Getting some responses. I appreciate it. Thank you. 9 p.m. is correct. If you look at the time, time is on the x-axis here where we'd like it to be. There's the temperature at 9 p.m., which is about 55.5 degrees. And at 3 p.m., it's right here, which is about 54.5 degrees. So it's 1 degree warmer at 9 p.m. than it is at 3 p.m. Okay. Good. All right. Let's look at the next question. Approximately when was the temperature the highest? At about what time? Good. I see some folks kind of rounding it. Some others are trying to pinpoint it a little more exactly. I would say let's get our answer as close as we can to the correct time. And so some of you are kind of rounding that to 6 o'clock, which would be right there. And by 6, the temperature had come down just a little bit from the highest point. So I would say right about there. People are saying 5:30, 5:45, somewhere around there. I like 5:45 myself. Okay. It's a good idea to be as accurate as you can. And so it would even be okay to say about 5:45 p.m. Okay. Find another time that the temperature was the same as it was at 4 p.m. So look at what it was at 4 p.m. and find another time of the day when it was that same temperature. Okay. And I don't know why it always does this when I put these kind of forms on the page. There's always lines missing from a graph, and I don't know why it does that. But there should be a line right there. It should be going through right about 57 degrees at 4 p.m. So when we write across there and right at 8 p.m., it would be at the same temperature. So 8 p.m. Good job. Lots of people responding. I appreciate your participation. Did the temperature change more from 1 to 3 or from 3 to 5? When was the greatest change in temperature? From 1 to 3 or from 3 to 5? Okay. Interesting responses there. I'm getting some of both, and let's just take a look at it. So from 1 o'clock to 3 o'clock, the temperature changed. It went from about 50.5 degrees to about 54.5. So say 54.5 minus 50.5. So it went up about 4 degrees. Okay. That's from 1 to 3. Then I'll change colors so we can see it a little different here. From 3 o'clock to 5 o'clock, the temperature went, say, from 54.5. I wrote that backwards. I want to subtract here, so I want that number next. So it went from 58 and not quite a half. It's going to be about 58.25. So 58.25 0.25, 25 minus 54.5. And that comes out from 54.5 to 58.5 would be 4, which would be the same, but it didn't quite go to 58.5. It went to 58.25. So I would call that 3.75 degrees change. Okay? So this is the time that I really wish we were all here together in a classroom, because I'd like to have that discussion about what you guys that answered from 3 to 5, what were you seeing that had you choose that answer versus this answer? Because to me, I can kind of see that this one goes up more than this one. Okay, so we want the one that goes up more. Okay, somebody replied and said they just looked at it wrong. That's fine. That's why we're doing this, because we want to be able to look at it clearly and understand what the graph is saying. So the way to tell that, and guys, when we take the test on this unit, there's a question very similar to, I don't know if it's temperature or not, I can't remember on the test, but it's one that asks about some intervals on the graph like that and asks you which one, is a greater interval or which one is a bigger jump. And you need to be able to look at the graph and read it that way to understand. So the bigger change is from 1 to 3. The temperature goes up more from 1 to 3 than it does from 3 to 5. Okay. Does the graph, does this graph show that temperature is a function of time, or that time is a function of temperature? This is that vocabulary stuff that we've been getting to over the last few lessons. So this is really important for the way this graph is pictured for us. Which one of these statements is true? Is it temperature a function of time, or is time a function of temperature? We talked about how to word these kind of things yesterday in the review. Nobody's taking a risk here. All right. Yesterday there we go. Good. All right. So somebody answered and answered well. Thank you. Temperature is a function of time. Good. Okay. Some others jumping in here and joining in. Thank you. I needed to give you more time to type. Okay. Temperature is a function of time. That's exactly what this graph tells us. We always want to state it where y is a function of x. If we have a function, this graph is a function. It passes a vertical line test. And since it passes a vertical line test, it is a function. And so we always want to say y is a function of x. Output is a function of input. Dependent is a function of independent. All those things say the same thing. So temperature is a function of time. Okay. Think about what that would mean if this graph was not a function. That would mean we'd have to have one time where the thermometer told us two different temperatures. Like at 10 o'clock in the evening, it's 55 degrees and it's 58 degrees in the same exact spot. Like, that's not possible. You can't have two different temperatures in the same exact spot at the same exact time, right? So maybe in one part of the city to another, but then that's not what we're recording. We're talking about, the same spot where that thermometer's at. So, that's just something to think about. Why it matters that this is a function. It wouldn't make sense for this graph not to be a function. All right. When the input for the function is 8, what is the output? So when the input is 8, what is the output? $57. Good. So at 8 o'clock, the y value is 57. That's right there. So 57 degrees. What does that tell you? Well, it tells us that it's a function because for that input, there's only one output. There can't be more than one output for that input. Okay. All right. So good. I appreciate your participation once again. with the activities. Let's go back to Summit Learning. The next one, activity, is garbage. Or if you're, a highfalutin person, we could say it garbage. But it should be this one. Activity 3, garbage. Get zoomed in a little better. All right. Shouldn't take you too long to get there. If you're keeping that Summit Learning page open on a tab, then you should just be able to go right back and click on it. So should be there by now. The graph shows the amount of garbage produced in the U.S. each year between 1991 and 2013. Garbage in thousands of tons. Wow, that's a lot of garbage. Did the amount of garbage increase or decrease between 1999 and 2000? So find 99 and find 2000. Did it go up or did it go down from 99 to 2000? Good. Yep. Appreciate those couple of you that have responded. Good responses so far. Good job. Yep. Good. Ooh, I like the word increase. Nice. Okay. It went up. Here's 19. If this line is 2000 and this line is 95, 95, 96, 97, 98, 99, that's got to be 1999 right there, right? So 99 to 2000, it goes up. It increases. Okay. So we would say increase. Did the amount of garbage increase or decrease from 05 to 09? From 2005 to 2009, did it increase or decrease? Good. Good answers. Okay, I like it. Some of you are being pretty specific. If we're just going to give one word answer to this one, that's an awesome answer. The answer is yes, it did increase or decrease. I like it. If we're going to give a one word answer to this, we would need to use the word decrease. Okay. And I like that some of you are being a little more specific than that, because if we look from here to here, that's a decrease, right? Some are saying, well, it increased first and then it went down. So it did both. It increased and then it decreased. But when they give us the parameters, when they give us these two specific dates, those are the only two dates we want to look at. Okay? From 2005 to 2009, the amount decreased. Okay? And so we'll just leave it at that. All right. Between 1991 and 1995, the garbage increased for 3 years, then it decreased the fourth year. Now it says describe how the amount of garbage changed in the years between 1995 and 2000. So now they're giving us a range, and they do want us to be more descriptive. Okay. And so we would do that from 95 to 2000. We would say it decreased the first year, because from 95 to 96, that's going down. And then from 96 to 2000, everything goes up. So it decreased from 95 to 96, and then from 96 to 2000, it went up, or it increased. Okay. All right. Next page says this graph shows the percentage of garbage that was recycled between 1991 and 2013. So when you think about this first graph, the garbage, that one's kind of sad that it's going up, right? That it goes up over time. That means we're using more trash, we're producing more garbage, we are putting more things in landfills and polluting more and all that kind of stuff. So this is not a good thing that this one's going up. But then you look at this one, this graph shows the percent of garbage that was recycled, and this one, it's a good thing that overall this graph goes up, right? Because the garbage that is not being thrown into landfills is being recycled. So we like that number to go up. All right. When is the graph increasing? And we'll look for some ranges here, some intervals of time when the graph is increasing. So give me one interval of time when the graph is increasing. I'll give you one number from 1990. Okay, we're starting at 91. That's fine. So 91 is where we first see our first data point. We can assume that 1990 is below this one because it's not up here somewhere, right? If 1990 was up here, we would expect to see it there. But since we don't see 1990 on the graph, we can assume that it's down here somewhere. Okay, and that's okay. A lot of times in math, we can't do assumptions, but here's one where we can assume something. All right, so from 90 or 91 to 96, I like that because there it's going up. Okay. All right, and then from 96 to 97, 98, 99, it's about the same. 90 or 2000 is about the same as 96. But then in 2000, or we could, I guess we could even say from here because it's starting to go up here. Okay, as long as it's moving in an upward direction. So I would say from 98 to 07. 98 to 07, it's increasing. And then from 08 to 12, it's increasing. Right? So when is it decreasing? Well, 96 to 97, 96 to 98 is decreasing. Oh, 07 to 08 is decreasing. And then 10, 11, I guess that would be 11. I put that as 12 earlier. But 10, 11 to 14, 11, 12, 13. 11 to 13 is decreasing. Okay. If we were going to tell the story of change in the percentage of garbage recycled in the U.S. over this time period, we would give it, we don't have to be super detailed. We could make some general statements. In general, the amount of garbage that's being recycled has gone up from 1990 to 2013. But there have been periods of decline, like brief periods where it went down. But the overall trend, the overall shape of the graph is that it's increasing for the vast majority of the time. Okay, so we would just make some kind of a statement like that. All right, we've got to keep moving here. We're going to run out of time. Go to your next activity in Summit, which is, whoops, not that one. I can't get to that other. There we go. Activity, which graph is it? Okay. So go to the very next activity. It should look like this. Zoom in a little more. That might be too much. That'll work. For each situation, name the independent and dependent variables. Pick the graph that best fits the situation or sketch a graph if one isn't provided. So for the first scenario, they give us some graphs to choose from. For the second one, we'll sketch one. We're going to label the axes and we're going to answer the question, which quantity is a function of which? Okay. So number one, that's these three graphs we're going to choose from for number one. Jada is training for a swimming race. The more she practices, the less time it takes for her to swim one lap. Okay, so these aren't, we'll call this 1, 2, and 3. So which one of these graphs do you think represents this scenario for Jada? Is it graph 1, graph 2, or graph 3? Where Jada trains for a swimming race, the more she practices, the less time it takes for her to swim one lap. Good. First one to answer there is good. Another good one. 2 people have ventured answers, both of them correct. Good job, guys. Okay, so the 2 that have correctly answered number 1. Number 1 is the correct graph. And what we need to think about this is as she practices, it takes less time for her to swim her lap. So we want practice time to be our label here. Practice time. And this would be lap time. So it's kind of weird that we have time on both axes. We talk about a lot about we want time to be on the x-axis, but sometimes it's going to be on both axes, and that's fine. Okay? And so the more she practices, like if she spends 1 hour practicing, here's what it does for her time. You know, if she spends no time practicing, then this is her lap time. If she spends an hour practicing, then it goes down. And then if she spends another hour practicing, it goes down some more. Okay? Now notice the shape of the graph. It doesn't just go straight down because she's never going to get down here where it takes her 0 seconds to swim a lap, right? I mean, this is called, the technical term for this would be diminishing returns. The more you practice, you're going to keep getting better, but at some point it kind of levels off because you're just never going to get any faster, right? So there's an optimum amount of practice for her where she gets the fastest time she can, and then after that, more practice just makes her tired. Okay. So the question then is lap time a function of practice time, or is practice time a function of lap time? Say that correctly for me in a sentence, please. Good. Well said. Had 1 person answer. I think everybody else must be asleep. Good. Okay, another one. Thank you. All right. Lap time is a function of practice time. Okay, good. Another one there. Lap time is a function of practice time. We've got to have that down, guys. This is going to be on the test. Okay, you've got to be able to identify, once you have this labeled, that y is a function of x, and you have to be able to state that properly. Lap time is a function of practice time. Okay, so that's the thing for this one. All right. Next, it says Andre adds some money to a jar in his room each week for 3 weeks, and then takes some out in week 4. So we don't have a graph here, so we need to draw one. And I know you guys can't draw on your page like I can on mine. So we're going to start out with this. We're going to label this as weeks because we want time to be on the x-axis, and this is going to be money. Okay, I'm just going to put a dollar sign there. We typically are going to want money to be on the y-axis. The general rule is time on the x, money on the y. Okay. So at week 0, we don't know how much money he has, but we could even just assume that he starts out with no money in his jar. Week 0. Week 1, he adds some money in. Week 2, he adds in some more money. We don't know if it's the same amount. You know, he might add a bunch the second week. We just don't know. And then week 3, he adds a little more, right? And then what happens week 4? Week 4, he takes some money out. So his money is down here at week 4, right? So it goes up and then it goes down. So is money a function of weeks, or is weeks a function of money? Y is, if the graph is a function, then y is always a function of x. Somebody asked the question, is y always a function of x, or how do you know? If the graph is a function, like all 3 of these graphs are functions up here, right? And so however we labeled those, y would be a function of x. Okay, this one, whoops, this graph we just drew, it is a function. And so y is a function of x. It would be money. The money he has in the jar is a function of weeks, of whatever week it is. If you want to know how much money he has in his jar, you would need to ask the question, what week is it? If it's a week 3, it's going to be more money than he had week 4. If it's week 3, it's going to be more money than he had week 2, right? So y is always a function of x, yes. All right, guys, you do have an assignment today. It's short. It's like, I think, maybe one question, but it's got parts, and it's on assessment. So you need to go to Google Classroom. Google Classroom, see if I can get there without totally botching everything. Classroom, I'm showing it on the video right now. You can't see it. I'll have to show it to you guys here in a minute. First hour. Okay, it's under the classwork tab. It's right here. It's lesson 8.5, lesson 5, more graphs of functions. And it's an assessments assignment, so you'll put your answers right there in the assessments. Okay. All right. I'm going to stop sharing. No, I'm going to stop the recording first. Stop the recording, then stop sharing. Okay.